In our previous screencast, we showed how Niels Bohr came up with the remarkable idea that electronic emission creates light. In this screencast, we'll show how deeply the evidence is supporting this, especially through the hydrogen emission spectrum. We'll understand the hydrogen emission spectrum and see how it gives rise not only to the visible series, where electrons are moving into shells to the second shell, but also the infrared series as well as the ultraviolet series. This is screencast 5.7. Well, it all fits beautifully. Imagine you have an electron in the first shell. It goes out to I believe that would be the third shell. That's atomic absorption or electronic absorption. It absorbs energy. Fine. No light is created. However, let's bring it in from that third shell to the second shell. That is going to create a 3 to 2 transition going in. Solving the Balmer formula tells you it should create red light. In fact, you see a red line for hydrogen. Let's take an electron in the fourth shell, move it down to the second shell. That creates the observed line at 486 nanometers, kind of greenish. Fifth to the second, the teal or bluish line at 434 nanometers. And finally, even the sixth to the second does create a faint line at, what is it? That's some wavelength. And so all of these give rise to the visible series. If it ends in a different shell, let's see, it looks like the third shell is the infrared series and the first shell is the ultraviolet series. It's all just math, and it's proven over and over again when you look at these spectra. It's all a matter of electrons going from one shell to the other. It all fits nicely. Our symbol for Bohr is the target. Each of the target represents the shells. Atoms reside in shells. This is screencast 5.7. Electrons reside in shells.